Hello everyone. In this video, we will be discussing some of the clutches problem. Already in the previous video, we had discussed single plate clutch problems. So in this video, we will cover multi-plate clutch problems and even cone clutch problems. So all the problems like multi-plate clutches and cone clutch problem I have taken from VTU prescribed textbook Design of Machine Elements authored by VB Bandhari. So we'll move to the first problem in this video. A multiple disc clutch transmit 50 kilowatts power at 1400 rpm. Axial intensity of pressure not to exceed 0.121 Newton per mm square, and the coefficient of friction of the friction surface is 0.12. The inner radius of the disc is 80 mm and zero point 0.7 times the outer radius. Okay. Determine the number of discs required to transmit the given power. Assume uniform wear condition. So unlike the previous problem, here also they mentioned assuming uniform wear condition. So until or unless they mention in the question, go with the uniform pressure condition. Always go with the uniform wear condition. This problem they clearly mentioned uniform wear condition. In case if they would have not mentioned also, would have gone with uniform wear condition. So let me write down the given data. So P is 60 kilowatt and power, and the speed is 1400 rpm, and the pressure is 0.15 Newton per mm square. Coefficient of friction 0.12, and the radius R2 is 80 mm and R1 is R2 by 0.7. So outer radius is 80 mm. So inner radius 0.7 we need to find out. So first solution, the axial resisting force per pair of contact surfaces F is equal to 2 pi P max into R2 into R1 minus R2. So I know the P value, R2, R1 value. While substituting in this axial resisting force formula, I am getting the force as 2585 Newton. And the second one is friction torque per pair of contact surfaces. So the formula is number of contact surfaces into mu into F into R1 plus R2 by 2. And here they have not mentioned number of contact surfaces. Let me go with 1. So with the what is that coefficient of friction value like 0.12 into the torque, what is the force value 2585 with the radius value R1 R2 like 0.08 by 0.7 plus 0.08 into 1 by 2. So I'll be getting frictional torque TF is equal to 30.13 Newton meter. So finally, the total torque to be transmitted is equal to T is equal to P into 60 divided by 2 pi n. So it is 50 into 1000 into 60 divided by 2 pi into 1400, which is equal to 11.3, approximately 12. So very simple problem, and we shall move to the next problem, that is a cone clutch problem. So a cone clutch with asbestos friction lining transmits 25 kilowatts at 600 rpm. The coefficient is 0.25 and the maximum intensity of the pressure is 0.25 Newton per mm square. The semicone angle is 12.5 degree. The outer diameter of the friction lining is 250 mm. Considering uniform wear theory, determine three things we need to find out: the inner diameter of the friction lining, the face width of friction lining, the force required to engage the clutch. So the given data, let me write down, and this is the cone clutch problem. First cone clutch problem we are solving in this video. So given power 25 kilowatt, speed 600 rpm, pressure 0.25 Newton per mm square, coefficient of friction 0.25, and phase angle or semi pressure angle, whatever we call, it's 12.5 degree, and 2 times of the radius 2 times of R1 is equal to 250 mm. So the torque transmitted by the clutch for the cone clutch, it is T is equal to same formula, P into 60 divided by 2 pi n. So substitute the value of P as 25 and n as 600. I am getting the torque value is equal to 397.9 Newton meter, and friction torque TF is equal to 2 pi mu divided by sine alpha into P max into R2 into R1 square minus R2 square by 2. So this is the formula exclusively we'll be using for the frictional torque for cone clutches. So while substituting the value of mu, alpha, P and R1, R2, since R2 is unknown, like a TF value I'll be getting in terms of R2. So the value I'll be getting it as 0.9072 into R2 into 125 square minus R2 square. I'll be equating equation 1 and 2. So that is R2 into 125 square minus R2 square is equal to 438602.3. So by trial and error method, I'll be finding the R2 value as 107.44 mm, and inner diameter is 2 times of R2, so 2 times of 107.44, which is equal to 214.88, and B value is the R1 minus R2 divided by sine alpha, that is 125 minus 107.44 by sine 12.5 degree. So B value I am getting it as 81.13 mm. So next is second thing, that is force required to engage the clutch. The formula is F is equal to 2 pi P max into R2 into R1 minus R2. So that is 2 pi into P 0.25 into P max, the P max value, that is the radius value, 107.44 into 125 minus 107.44 into the P value 0.25. If you substitute, means we will be getting the force required to engage the clutches 2964 Newton. So we have two more problems to discuss that we will discuss now. Simple problems. Okay. An engine developing 45 kilowatts at 1000 rpm is fitted with a cone clutch built inside the flywheel. The cone has a phase angle of 12.5 degree and a maximum mean diameter of 500 mm. The coefficient of friction is 0.2. Normal pressure on the clutch face is not to exceed 0.1 Newton per mm square. Determine axial spring force necessary to engage the clutch and face width required. So given data, P 45 kilowatts, speed 1000 rpm, and pressure angle 12.5 degree, diameter 500 mm, so radius 250, quotient of friction 0.2, and the pressure 0.1 Newton per mm square. So first we need to find out the axial spring force necessary to engage the clutch first of all. So let us find the torque developed by the clutch and the normal load W acting on the friction surface. So we know that power developed by the clutch P, that is 45 into 103, which is equal to T into 104.7. So therefore T is equal to 430 Newton meter. Simple calculation. And we also know that the torque developed by the clutch T, so that is 430, which is equal to mu into W into N into R. So here Wn will be the unknown, so I'll be getting the value of Wn is 8600 Newton, and the axial spring force necessary to engage the clutch, so that is Wn sin alpha plus mu cos alpha. Substituting the alpha value 12.5 degree, I'll be getting the axial spring force value, that is 3540 Newton. And second one is phase width required, that is B. We know that the normal load acting on the friction surface, which is 8600, which is equal to P into N into 2 times of R into B. So after substituting all the known values, the phase width value B value I am getting as 54.7 mm. And moving to the last problem, a conical friction clutch is used to transmit 90 kilowatts at 1500 rpm. The semicone angle is 20 degree and the coefficient of friction is 0.2. If the mean diameter of the bearing surface is 375 mm and the intensity of normal pressure is not to exceed 0.25 Newton per mm square, find the dimensions of the conical bearing surface and the axial force required. So write the given data: power 90 kilowatts, speed 1500 rpm, and the quotient of friction is 0.2, angle 20 degree, and diameter 375, and pressure 0.25 Newton per mm square. It is very similar to the previous problem. So let R1 and R2 are the external internal diameter of the radius, bearing surface respectively, and small b is nothing but width of the bearing surface. So capital T, torque transmitted. So the power transmitted formula, let me write in terms of torque. So 90 into 103, which is equal to T into 156T. So here we can able to find out the T value. So the torque transmitted T value I am getting as 577 into 103 Newton mm. So which in turn I will be equating this relation, that is 577 to 103, which is equal to 2 pi mu P n R2. So here I need to find out the phase width values, that is 2 pi into 0.2 into 0.25 into 187.5 into 2b. So finally I am getting like 11046 b. So the b value will be 52.2 mm. It is 110.46. So we know that R1 plus R2 is equal to 2R. So which is equal to 375 mm. That will be equation 1, and R1 minus R2 is equal to B sin alpha. So that is 18 mm. So equating 1 and 2, I will be getting R1 as 196.5 mm and R2 is 178.5 mm. And similarly, the axial load required, we can find out the same method, where I am getting the axial load W value is equal to 5045 Newton. The same formula what I have used in the previous formula, that is 2 pi C into R1 minus R2, where C is nothing but Pn into R2. So by substituting the value of 44.6 as the C value, we'll be getting the axial load as 5045 Newton. Thank you.